right? Right. Right. Uda, listen to me carefully. Do you know conductors? What are conductors? Very good. Materials that conduct electricity. Right. What are examples for conductors? Magnesium, iron, aluminium, right? All of these are metals. Very good. These are what? Metals, right? Buddha, there is a property of metal like sodium, magnesium, everyone. They make positive ions by releasing electrons. Do you remember something like this? Huh? If magnesium was there, magnesium becomes magnesium Mg2 plus by removing 2 electrons. Do you remember something like this? Right. That means metals remove electrons and make them free to move. Understood? Right. Metals remove electrons. Then they become free and move. Right. Huda, what is the charge of this electron? Negative. Think about this. This is a metal. Right? It has many free electrons. Why? Metals remove electrons. Understood? Right. If this is a conductor, this should be a metal. It should have what? Free electrons, because metals remove electrons. Right? Okay. These free electrons are the reason for them to have ability of conducting electricity. What is the reason for ability of conducting electricity by metals? Free electron. Free electron is the reason that they make as conductors. They become conductors due to what? Free electrons. Right? Free electrons, conductor. Conductor, free electrons. You have to keep in mind that. Right? Okay. There is another kind of material called semiconductors. What? What are semiconductors, Buddha? Semi means bagit. Semi means half. Materials that partially conduct electricity. Materials that partially bagit conduct electricity. Why? Why these are conductors and there are some things called semiconductors? What is the difference? What are the examples for these? Silicon, germanium, example. These are enough. Right? Let's study about silicon now. Right? What is the group of silicon and germanium, Buddha? Tell me the group of silicon and germanium. You don't know about germanium, right? But these two are in the same group, not in the group 3. Group 4. Carbon and below the carbon is silicon. Right? You remember? In the periodic table, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon. What is the group? 4th. Under the silicon or below the silicon. What is that? You can find germanium. These are group 4 elements. Understood? Right. What is the valency of group 4 element? 4. 4 is the valency. Group also 4. Valency also 4. So, this silicon have 4 electrons. They like to have bonds. Am I correct? Valency 4 means they should have 4 bonds. Right? This silicon can bond with another silicon atom. They like to have bond. Am I correct? Right. If there was another silicon atom, these two also like to have a bond. Right. Similarly, this becomes a huge lattice of silicon with bonds. Here also with the bond with another silicon here, they bond. Now I think you can imagine what happens here. This does not end. This is a huge lattice. Hands up if you understood this structure. Why there are 4 bonds? Silicon is in the group 4. Group 4 elements can have 4 bonds. Carbon can have 4 bonds. Germanium can have 4 bonds. Right? Okay. Keep this in your mind. Right? You can find this kind of structure when the temperature is equal to 0 Kelvin. What happens, Buddha? Not there. When the temperature is equal to 0 Kelvin, Pujita, this is the most important part. Huh? If you did not understand this part, you will not able to understand the whole lesson. Careful. Right? Very small things collected together and make big things, no? This is the most important small part. Right? This lattice you can find in which temperature? 0 Kelvin. You did not heard that, I think. Right? If we increase the temperature by supplying heat, right? If you supply heat and increase the temperature, what happens? Heat is a kind of energy, no? Right? What are the meaning of these dots? These are electrons with a negative charge. No? Right? If we heat this structure, these electrons get the energy and remove from the bond. That is happening. Right? What happens? Let's use this arrow below, down, right? Increase heat, and what happens? The structure change, silicon bonds, this bond, remove electron and it comes out. Why? Due to the heat energy, right? Do you know the meaning of 0 Kelvin? 0 Kelvin means, what is it in Celsius? Minus 273.5, no? 5015. 5, no? Sometimes 15. The first lesson, Buddha, we studied, no? Heat lesson, huh? Right. The accurate value is 207 minus 273.15, right? In the room temperature, this increases by more than 300. Uda, can you think about minus 273 Celsius? 0 mean equal to ice cube, no? Minus 200 mean, how cool is that? Very cool, no? Right? In room temperature, in this environment temperature, this structure is heated or not automatically? Automatically heated. That means automatically these electrons come out. No need to supply heat. Right? Environment supply heat and this structure becomes a what? Semiconductor. Why? Electrons come out. So, here in this silicon also, what happened? Electrons come out. Most of the silicon atoms, what happened? Electrons come out from the bond, right? So in this case, you can find many electrons, we can call these as free electrons. Am I correct? Right. So what happened to these? What is this one? Hole. What is this, Buddha? Hole. Hila. Why? Electrons removed from this place, no? There is a deficiency of electron. Deficiency means that hole is trying to have electron. Deficiency, give me electrons, something like that. This hole needs electrons, right? However, there are two types. What? Free electrons act as negative and holes act as what? Positive. Why? Hole likes to have electrons. Then it appears as a positive charge. Understood or not? Right? So, in this structure, there are two carriers. Carriers mean in the conductors, electrons are the carriers of current. Am I correct? Electrons are the carriers of current. In this structure, there are two carriers. What are they? Free electrons and holes. Both of them are what? Carriers. Current carriers. Right? Right. Okay. However, in this silicon structure, can you find any other material instead of silicon? Silicon is there. Any other one is there? No. Nothing. Right? That means this is a pure silicon semiconductor, no? Right. Here we can divide semiconductors into two types, Buddha. Intrinsic semiconductors and the other one is extrinsic semiconductors. Right? Do you know the difference? Intrinsic semiconductors are pure semiconductors like what? This silicon, germanium, right? No any other mixed things, no? Right? If we mix something here, right? If the intrinsic semiconductors mixed, here we use new word instead of mix, doped. What is that word? Doped. Doped is a similar word for mix, but we use it in electronics. Understood? Then if the intrinsic semiconductors, these are mixed. From now it is not mixed, but it is doped with another element. They are called what? Extrinsic semiconductors. Now you can find two types of extrinsic semiconductors. First one is P type. P type. P type means positive type. Understood? And the other one is N type. N type means what? Negative type. Right? These are negative carriers, no? Electrons. Right? If there are more electrons than holes, they are what? Negative type semiconductor. If there are more holes, positive means holes, no? More holes than what? Free electrons. They are P type, positive type semiconductors. Understood? More holes, more negative. N type, more holes, that means more positive. It is P type. More electrons, that means more negative. That means N type. Right? Okay. To build P type semiconductors, we have to do something called doping. Doping is equal to mixing. Right? We are mixing, right? We are mixing, not the mix, but doping group 4 element with group what? 3 element. Like boron, aluminium. Why? Why group 3 with silicon? Shall we look at the structure? Think about this one. Kuta, this is silicon. Right? Silicon have 4 electrons and it like to bond with another silicon. If the bond is with more temperature, some electrons may gone out. No problem with that. If there was an atom like aluminium, what is the valency of aluminium? 3. 3, no? Aluminium in the group 3. Group 3 means 3 bond. Group 3 means 3 bond. Can it have 4 bonds? No. Then aluminium make 3 bonds and one is whole automatically. No? Automatically it becomes a whole, right? Then we mix aluminium more, we can have more holes. Am I correct? If we mix more aluminium, right, this semiconductor is consist of more holes, right? Then it becomes what? Positive type semiconductor. Why? There are more holes. Clear or not? Clear, right? I'm using very simple English words. I'm not using complicated ones. That's why I'm using this. If you cannot understand this type, I don't know about you. I am using very simple words. No, this, the, look, like that. I am trying to make this very basic and make you understood this lesson. Right? Carefully listen. I know that you can understand. Right? Okay. Now we are moving to the other side. Right? You know that this semiconductor have more electrons or hole? Hole. Other type should have more electrons. That means we have to mix group what? 3? No. It is not enough. No. 4 is equal. No. 5. 5 have 5 electrons. Right? That means it have one extra electron. Understood? Then nitrogen is a gas. No. We cannot mix a gas there. Right? Nitrogen is a gas. Can we fix a gas there? No, it is not possible. So you can have what? Phosphorus, right? Then you can do dope the silicon lattice with group what? Group 5 element and you can have more free electrons in the lattice. Right. Shall we look at the structure? Okay. Think about silicon. One silicon is there, another silicon is there, another silicon is there, one phosphorus is there, right? These have 4 electrons. 1, 2, 3, 4. 1, 2, 3, 4. These have how many electrons? 5 electrons. That means 1 extra. Completed. Right? There is 1 extra electron. Now can you understand this structure? This is extra free electron. That means there are more electrons than holes. Am I correct? That means there are more electrons than holes. That is why we call this as which type? N type, negative type semiconductors, right? Did everyone understood this part? Clearly? Easy, no? Right. Do you like to write the note or let me continue the lesson? You like to write the lesson? Okay, write it down. If I teach more, it will more complicated, no? Yeah, you got it. Carefully write it.